Hey everyone, thanks for joining us at DCiOS again. If you're new, welcome. I see a lot of new people on our participants list today. We have an awesome talk coming in from Victor, employee at, or he's a lead developer at Capital One. He's giving us a talk on not technical explanations of unit tests. We'll have some more updates and stuff for DCiOS at the end after this. After Victor has questions and whatnot. So feel free to shoot any questions that you have during the presentation in the chat. That way we can get to them at the end and we don't forget. Or hold off to the end. We can you can raise your hand and we'll on the Zoom, and then we can just unmute you and then allow you to ask questions. So Victor, you want to go ahead?
Thank you, Joseph. Hello, everyone. My name is Victor Lopez, and today I'm going to talk about unit tests. So I chose this title so no one expected code. Basically, that's true. I'm not going to show any code, but don't worry, I will still have like some tips on how to write good unit tests. And what I really want to do is share my story around unit testing. How I went from like not writing any test, from not seeing like basically the reason to do so, to write tests for every single code I write, and also to preach about it, about unit testing, to the point that now I'm like giving this talk so I can have like everyone get on the same mindset. Before the talk, who am I? As Joseph mentioned, I'm an iOS software engineer at Capital One. Currently, I'm the tech lead and a manager on a team that works on the Capital One's flagship iOS app. I've been working in this app for maybe 5 years. I've been working in Capital One for like almost 7 years. 6 years as full-time employee, 1 year as a contractor. I was born, raised, and studied in Mexico City. And I say studied because back there in college, I had like an iOS development class, and that actually made me to be here working in an iOS application. In terms of like what I really like music, rock, indie rock, alternative rock, sports in that order, basically, soccer, football, and baseball. Food, not in that order. I'm biased. I really like Mexican food. For me, it's like the best food in the world. And I also like watching movies, like going to the theater, the entire experience. And then like after I watch a movie, I really like reading about like the technical details of the movie, actors, actresses, production, directors, etc. As I mentioned, I want to share my experience, my story about how I used to see unit tests when I started programming versus how I see them now. I will talk about like the what, the why, and the hows of unit testing. And I want to show you how those like answers showed me the benefit of unit testing, which eventually made me realize the importance of unit testing. So how like this journey started. In my early developer days, I knew unit testing was important, kind of like I never saw the benefits. It was always suggested, never enforced. Even Apple, like they have information about unit testing, but it was like not that much shared. I remember attending like many talks in many different conferences about unit tests. Again, I wanted to be important to me. Like I actually wanted to do it, but it kind of like never clicked. And the more meetings or the more conferences I went to, I kind of like started like realizing more and more benefits of unit testing. And sincerely, when I started, I didn't even know how to do unit testing. I always felt overwhelmed. And I remember a while ago, I had to do a feature for the Capital One app. And I did all the code. It was basically a view controller. There was like a lot of logic there. And then at the end, I wanted to do some unit tests, and I just didn't know how to do them. Like it was difficult. I didn't know what to start. I didn't know what like to actually test. So I'll like in this talk, I basically will tell you how to avoid that, and then how I see now code that basically enables me to write unit tests. Also, something kind of like in the industry started to change. Basically, iOS code is not ephemeral anymore. Apps are here to stay. Many companies, basically the serious companies, they have an app in the App Store, and they will continue having them for a while. meaning that now we need to maintain all those apps, meaning those apps are going to be like 4 years, 5 years, or even more. And meaning that we want to have and maintain those apps. We want those apps to be good. We want those apps to work for our customers. And we want to also to keep incrementing the features of our apps. Same-wise, I started to change. I started to think differently. I started to understand the what, the why, and the how of unit testing. And from these questions, from the answers of these questions, I started to see the benefits of unit testing. So for us to, for me to show you what changed in my mind, so I will answer like these 3 questions, the what, the why, and the how. So we'll start with the what. So what is unit testing? A very simple definition is verifying an isolated piece of code works correctly. A little more technical definition is running a sample scenario and checking the observed outcome matches the expected one. Then we have FIRST. FIRST is an acronym that describes how unit tests should be described, basically tells you how unit tests should be working. Sorry. It was described in the book Clean Code by Bob Martin. FIRST implied that tests have to be fast. They have to run as fast as possible. They need to be isolated. They should not depend on any other unit test or in an external state. They need to be repeatable. They always have to produce the same result. They have to be self-verifying, meaning it either passes or fails. There's no ambiguity. And they need to be timely. Unit tests should be written at the same time as the code for testing. And this is very important. For me, unit tests are an investment. Yes, at the beginning, it's hard. Yes, at the beginning, it will take you some time. And obviously, if you write production code and unit test code, you will not be able to deliver that much production code at the same time. But again, it's an investment because then you'll see more benefits long run. And finally, I want to make a differentiation between integration tests and end-to-end tests. We all know the testing pyramid. We know that integration tests are basically testing that the two units working together. It can also apply to like larger systems. For example, if your UI or like your business logic is getting like the data from a database in core data or things like that. And end-to-end tests are basically testing entire flows. They could be manual tests or they could be automated tests. So then the next question, why do we want to unit test? The simplest answer also is to verify that our code works. That's basically the definition. But if you have good unit tests, also it enables you to do big changes, easier refactoring. And then it also gives you some quality.
Sorry, I didn't quite catch that. Could you please repeat it?
Excuse me. So I have a quote there, quality assurance, not quality insertion by Graham Lee. I will go back to this quote later. But again, in terms of quality, how does unit test or why unit testing? So if we have a bug, we can always create like a failing test before we start to fix it. And then if we do so, we will make sure that things are never broken again because we already created a unit test to fix that bug. So it will keep running. And finally, it prevents regressions. If we have meaningful tests, we can catch problems before integrating our changes. So then back to the quote, quality assurance, not quality insertion. Basically, this means that tests only show us that our code works as expected, which is not the same to say that they help us uncover bugs. This means that automated tests only verify the expectations we provide them with. Again, they don't help discover new bugs. So I want to make that clear. And also I want to have like this disclaimer from this quote from Spider-Man. It's important to mention that tests are just code. Obviously, they can have bugs. Obviously, they can be written with the wrong specification because tests can explain the client specifications to the developer. They can clear up ambiguities. They can show the developer understood or not even consider the fundamental problem trying to be solved. And finally, they can't identify all the bugs. So we need to be conscious about unit testing. Also, a recommendation for us to try to address this type of issues is to have a robust testing suite. We can have some integration tests to make sure that things work correctly together. And we can have some end-to-end tests, again, both manual and automated, that verify the user experience. And finally, for us to kind of like prevent these things to happen, we need to write good unit tests. So how do we write unit tests? I can change the question to how do we write good unit tests? Obviously, we have to start, right? So the most common answer for how to start question is usually just start writing tests. And then I'll read a quote from Paul Hudson. Each test written adds another small piece of certainty that your code behaves as you expect. The more tests we write, the more assurance we will know, or we will have, sorry, that our code works correctly, that our app is doing what we intend to do. So that now we can like separate how to start in two different types of code bases. If you're dealing with a project which has like no tests, the suggestion is to start small. One bug is a quick example. Also try to look for like the simplest units available. Try to identify what is the easy to test. Sometimes we like to put like print statements. Sometimes we like to put like debug breakpoints. You can, instead of doing that, you can like have some tests instead. Also, another recommendation is to test the most critical code or what basically breaks the most. You will have a win-win situation right there. And because static coupled code is hard to test, a suggestion is to split like small pieces and then write tests for those small pieces. If you are starting like a new project or like a new feature, think TDD, think test-driven development. I'm not preaching to do test-driven development, but like have it in your mind whenever you are like writing a new feature or like a new project. So why TDD? Because if you think it the other way, if you try to add tests after writing the code, it's going to be like very, very hard, almost impossible to isolate like a single component simply because they weren't designed to work in isolation. And coming back to my struggle back in my early days, in that like big view control that had like a lot of logic, because I wrote everything for it to work, and then I wanted to write some unit tests on there, I couldn't do it because everything was like very, very tightly coupled. Like that view controller had like not only like the view or like the view layer or the view responsibility, it had like business logic, it had like a bunch of things that was like impossible to test. Another suggestion is to keep things within the context. We shouldn't go around and trying to do different things at the same time. Same with everything. Same with code, same with work, same with life. If we just focus on one responsibility, things are very easy. Another suggestion is to use unidirectional data flow. And I'll explain it with an example. So let's pretend we have a view that then produces an action, and then that action updates a data model, and then that data model can update a view model that then is going to be consumed by the view. If we think it that way, it's very easy to read, right? And then all these little components can have states, and all those little components can have like methods that have input and output. Then another recommendation is to have an architecture set up for testability. And finally, to structure our code to be testable. But so how do we structure our code to be testable? This question kind of like shifts the focus from like unit test to the code itself. How do we write testable code? How do we structure our code to be testable? So there are like many different suggestions that we can follow for us to achieve it. First one is to follow SOLID. SOLID refers to 5 design principles intended to make software designs more understandable, flexible, and maintainable. The first principle is the single responsibility principle. Your type should have only one responsibility. When designing types, ask yourself, what are the responsibilities? And this is crucial, right? Like, again, I mentioned it many times. If you have types or objects that only do one thing, writing tests for those things are going to be very, very simple. Second principle, the open-close principle. A type should be closed for modification, but open for extension. Third principle, the least scope substitution principle. Basically, it's like thinking protocol-oriented programming. We should be able to replace types through an interface. And this is very useful in unit testing because if you are always talking to an interface, not to a concrete type, you can always mock the dependency of that specific object. The fourth principle is the interface segregation principle, which tells you don't use bad protocols, meaning that methods in a protocol should be related. Again, you don't want like your protocols and then like the objects that conform to those protocols to have like multiple responsibilities. And then the fifth principle is dependency inversion, which is basically dependence injection. When we inject dependencies to an object in unit tests, you can then mock them to do some sort of testing. Another suggestion is to manage your dependencies, like very related with like the previous dependency principle. But then the suggestion here is to don't have like many different things in your objects and basically be pulling data in from all of those objects. Because if you have to have like many lines of code to start like setting up stuff for you to do some unit testing, most likely you're not going to do it. Another advice is to manage complexity. If you have very, very large methods doing like a bunch of things with a bunch of like code branches, if else's, switches, it's going to be hard. It's going to be hard to maintain, and also it's going to be hard to read. Another suggestion is to keep things simple. You don't have to have very complex code. Same as tests, code should be simple and readable. You can then play with composition. You can start like having building blocks and like build your features from those building blocks, and you can have like a layer architecture. Another suggestion is to separate testable from untestable code. We can always separate UI with business logic. And I suggest like separating UI with business logic because UI it's always hard to test. Another, which is relatable, is to represent untestable things as data. You can always have like a little struct that represents like a state. And then in your view layer, you can like pass that state and have like an update method. Again, UI actions, callbacks, and all that stuff from UIKit are like not very well testable. They are, but it's very hard. So you can like shift that into a struct. And also related, if you have a simple layer, that's very helpful because all the code in the storyboards in view controllers and view are not like tested easily. Also, like a recommendation is not to have like that much code in a view layer. Like some recommendation that I've heard many times is that like views should only update UI and handle actions. And then you can pass all that logic to some different objects. A little bit more technical recommendations here. Side effects, like avoid using side effects and external state because they are not easy to test. You are basically booking other objects. You are most likely not testing only those objects, but like all the other objects you are modifying. Like instead of like poking directly also to some properties, you can have like some update methods that like get some parameters and then produces some output. Another recommendation is to use constants rather than variables because mutation is hard to track. Also treat singletons with care. Like if mutation in your objects are hard to track, imagine like mutating like this shared object by who knows how many users. Another recommendation is to have methods only doing one thing. We talked about it with objects, with types, single responsibility, same with methods. Because if you are testing a method and then you have like a bunch of different assert lines, maybe there's something wrong, right? Like maybe you want to split those methods into multiple methods that like do just one thing. Think also of pure functions, like not to the point to talk about functional programming, but like if you have input and output, it's very easy to test those things. Another recommendation is like make impossible conditions impossible, meaning like sometimes we want to have like two different types of results, but then like because some Do I keep components? They actually, in callbacks, they give you like either a value or an error. Like try not to do that. Like a recommendation here is just to use result instead. And then a final recommendation is to mark methods as private or file private, because you should only focus on on like the parts that are exposed. We should think that we should be testing behaviors and not lines of code. And then most of the time, those public methods will eventually call some private or file private methods. So then if you are really concerned about coverage, then you can focus there. So now that we talked about how to do testable code, we can come back to unit tests. So here are some unit test tips on how to write better unit tests. The first one is to treat your code with the same amount of care as your app code. Most of the times we do unit tests again at the end, and we don't give them as much as importance as like a production code, but it's very, very important to do so. Also, about making changes to production code with testing code. Like try not to add testing code or like paths in your production code. We want like a clear separation of what the tests and the shipping code do. Another suggestion is to choose like a correct naming pattern. We want to be good with naming. I mean, naming is hard, but like if you choose like a good pattern in your unit test that like easily identifies what the unit test is doing, what method it's calling, and what's the output, that's very, very useful. Also, another recommendation is to follow the arrange, act, assert pattern. And finally, you should have like a mix with integration tests and end-to-end tests. You can have integration tests verifying the entire flows. And then when something breaks, your unit test can like very, very easily point what went wrong. So from all these previous suggestions, like mainly the ones on like how to write unit testable code, we can like apply that to basically like those answers, we can apply them to how to write good code. In order to write easier and more useful unit tests, we need better code. As simple as that. When the code is in great state, writing tests that prove your code is working is easy. It's basically almost obvious. And basically that idea of that unit tests helped me writing better tests, that was like the main driver of my mental shift of not liking doing unit tests to really enjoy writing unit tests. I want to be a better software engineer. And again, unit test helps me and like, in a way forces me to write good code. And why do I say like it makes our code better? Because it reduces the complexity of our code, because it reduces the coupling in our code as well, because it enables us to choose better architectural decisions. And on top of having like better code, it also has some other benefits. Unit tests also work as documentation. It can show ourselves, our future selves, some of the coworkers we have, how the feature works. We can also focus on like the most important things of our code. If we write tests for like the most used thing, everything is going to be basically documented in those unit tests. Also, it helps us avoiding testing things manually. Like how many times have we tried to go to that specific screen where we want to see like our code worked? So instead of that, you can have like unit tests that are like run immediately and then verify that your things work properly. And finally, as I've been mentioning before, it helps you refactor easier. So with all these benefits, I really hope I convince some of you guys of, or shown the value that unit tests have. And if you don't have any, or if you don't write any tests, or if you struggle with tests, I really hope with all these tips, you have like some idea of how to start or how to write your unit tests. Here are some of the references I use for this talk and some of like good sources that I really like following. Thank you. If you have any questions, please let me know.
Hey everyone, if you have questions, feel free to click on the yes button next to your name. We can unmute you to ask. Otherwise, I wanted to just toss in a few updates that we have coming up this month and next month. So if you're new here, DCiOS happens the second Tuesday of every month at 6 p.m. We'll be doing it virtually until further notice. So keep an eye out on that Meetup site. Other than that, we also have are planning to do like a watch session for WWDC, which I believe is this month on the 22nd. So we're really excited about that. So just keep a lookout on the Meetup site. We'll post all those events for you. Victor, we have a question. Can you post the slides before the last one?
Second, like, what do you mean?
Craig, you just want to see them, or we'll post all the slides too. I should mention that we'll be posting all the slides as well as the video for this presentation on YouTube. There'll be the reference slides, the one he's looking at.
Oh,
yep. Yeah, so we'll be posting his entire slide deck and video on YouTube as well to reference later. If I'll post it in here, the link to the DCiOS Twitter account, and then some useful links for the YouTube account as well. Yeah, so definitely follow us on Twitter. I just posted a link there on the chat. And then through Meetup, you'll be able to get to the meetup.com. In the bio, you'll be able to get to our YouTube channel as well. Not seeing any questions coming in from anyone. Yeah, let me unmute you, Craig, and then I'll let you give your announcement. Find where you're at. There you are.
First of all, Victor, thanks for the talk. It was good. I just wanted to say, I know I'm new to this group, but on Twitter, I've been giving out free mentoring for 30-minute slots. My plan is to give 100 slots by the end of the year, which equates to 30 minutes per person. So if there's anyone that you know that is looking for iOS help at any point, or if you are, I will start posting. I've already done 4 this week, and I'll probably do 4 more next week. But I don't want to post them all at certain times. So I'm basically just trying to get through 100 of them before the end of the year. So if anyone's interested, I'm willing to help. I know how iOS is, and videos and books are great, but having someone look at your code and go over things with you for something specific is more beneficial. So I just wanted to throw that out there for anyone that would like to follow me on Twitter for it. Thanks, Joseph.
Thanks, appreciate it. I'll go ahead and post your Twitter channel there, a link to it in the chat as well. So yeah, feel free to reach out to him. He's the author for a few books out there. I know the one I remember off the top of my head was last time we met was beginning iOS development. I can't remember if there's some sense, but it's been a few years since I think we last got to chat. Let's see. Oh, you're doing a new one for SwiftUI. Awesome. We're excited for that one now. I'm definitely looking to play with that one a little bit more. Any other questions from anyone? All right, if that's it, then we'll go ahead and post these videos on YouTube. We'll post the slides on YouTube. if you follow us on Twitter, it's DC_iOS. We'll be posting a link to that video and slides on there as well. And thank you everyone for coming.
Thank you. Goodbye.